Hello everyone to the MEC323 tutorial. We'll be going over these two questions that were used for the tutorial. Now let's start with question number 1. CD is a straight rod where D may be positioned at a different location on the circular rod. G is an elastic cord whose support at G lies in the YZ plane, and the bead at E may have different position D. Now for these values, B, H, D, and Z are provided. We must determine the coordinate of E. Now first, we look at the diagram and we're able to identify that E is in between C and D. Now, you should be able to recognize that if you have a point in between two other points which create a line, you can find it out through using unit vectors. Now, what we do have is point C, which we know is 0 I hat, 0 j hat, and 360 k hat. Next, our D. D is a bit more complex, but we're able to recognize that from the origin in 2 D should be 150 millimeters. This is because it is a circle, which means the radius is the same throughout. Now, we know that, but we don't know the X and the Y. So we're given B3 and H is 4. We can use similar triangles to figure out the X and Y coordinates. First, let's figure out the hypotenuse of that. So it's 3 squared plus 4 squared. And if you put that into your calculator, you're going to get 5. So using similar triangles, you say that dx over 150, which is the hypotenuse, is equal to, let's find the x-axis first, 3 over 5. So dx is going to be equal to 90 through rearranging. Then we have dy is 150, 4 over 5. And dy is going to equal to 120. And these are all in millimeters. So make sure you include your units. Now this is the easy way that I wrote it. So we're going to put our answer in. 90 I hat plus 120 j hat plus is going to be 0 k hat. And then this is all in millimeters. Now we have RC and we have D and we have C. So we can create RCD. So RCD, we're going to be saying the tail is C, the head is D, if you see through this line. Now we just do head minus tail. So 90 minus 0 plus, or I hat plus 120 minus 0 j hat, then 0 minus 360 k hat. This means that the RCD is going to be 90 I hat plus 120 j hat minus 360 k hat. Now, from here, we are able to figure out our unit vector. The formula for unit vector is just the vector itself divided by its magnitude. Now, to find the magnitude, you just have to square all these numbers and then take the square root of it. So let's put that in. We have 90 I hat plus 120 j hat minus 360 k hat. Divide it all by the square root of 90 squared plus 120 squared plus 360 squared. Now, when you put it into your calculator, you're going to get 390 on your denominator. On your numerator, you're going to still have your same values. Next, what we're going to be doing, we're going to be finding the unit vector, which means we're just going to calculate these values. So 90 over 390. My apologies, I'm getting a bit into the diagram, but hopefully you guys can still see the numbers. Now we have the unit vector for our CD. We can figure out what E is by doing the magnitude from C to E, which we know is given 195 millimeters, and that will give us RCE. So when you have RCE, you're just going to do 195 multiplied by the unit vector itself. So we're going to do that times 0.231 I hat plus 0.307 j hat minus 0.923 k hat. Multiply everything through. 195 times 0.231 . Now, make sure you include your units. Now we have RCE. We know that the formula for RCE is equal to RCE head, which is E, minus tail, which is C. So we can do RCE plus C is equal to E. It's very easy because we found C before. We have RCE, and we can just figure out E. So we just do that. 45 I hat plus 59.87 j hat minus 179.99 k hat. Then you just add 0 I hat, 0 j hat, plus 360 k hat. Now this will give us our point, which is just going to be 45.0 I hat plus 59.87 j hat. And then from here, this is going to be 180 k hat. And as you can see, we have our answer for E. Boom. This was the answer. Now, make sure you completely understand everything if you need to rewatch this part. Now I'm going to erase this and we're going to do part B. And I'm only going to keep the answer for E. Now, let's read part B. If the elastic cord supports a tensile force of 100 newtons, write the vector expression using Cartesian vector representation of force, e.g. the cord exerts on bead E. Now, for this, we're going to have to first find the unit vector of EG, then we multiply it by the force to get FEG. Now we have E. G is very trivial to find. This point is going to be, G is going to be at, we have to look at Z, 270, my apologies, 0 I hat, plus 150 J hat, plus 270 K hat. Make sure you include your units. That's how you get all your marks for the quizzes. And now we're going to find REG. This means that G is the head. This means G is the head. E is the tail. It's going to be, this means G is the head, E is the tail. It's going to be 0 minus 45.0 I hat plus 150 minus 59.87 J hat plus 270 minus 180 K hat. Perfect. Now we follow the steps, do the math. Now, we need to find that FEG is just equal F times the unit vector of EG. What are we missing for the unit vector? Well, as we stated before, the unit vector formula is the vector over its magnitude. So we have the vector, we just need to do the magnitude. Now we write it. Negative 45 I hat plus 90.13 J hat plus 90 K hat. Now we are going to divide it by 45 squared plus 90 squared plus 90.13 squared. My apologies. J hat and K hat in this situation, I flipped them. Now, 45 squared plus 90 squared plus 90.13 squared. Square root all of the answer. You're going to get 135. So 100 times negative 45 I hat plus 90.13 J hat plus 90 K hat divided by 135.1 will give you the unit vectors. Now this will be 45 over 135. 0.33 I hat .667 J hat and same thing, 0.667 K hat. Now we just have to multiply it by 100, and this will give us our components. So 100 times 0.33 is just 33 newtons in the I hat direction, plus 0.667 times 100 in the j hat direction. And then make sure we include our signs. My apologies, I made a mistake with the signs. And then finally, 66.7 k hat. Now, this was our final answer. Thank you for listening to question number 1. Now we'll be moving on to question number 2.